In the world of electronics, a whole lot of the devices that we use are semiconductors. And another day we'll talk a little bit more about semiconductors and integrated circuits. Today we'll talk about diodes and transistors. They are made from semiconductors, and usually that's silicon. The word diode comes from this root meaning two, and some clever person got the suffix off of the word electrode and stuck those two together. So a diode has two things. A transistor has three things. We don't call it a triode, but it does have three things, and we'll look at that in a minute. As you recall, an insulator is a material that does not allow current to flow. It cannot conduct electricity. All its valence shells are full. While a conductor has only 1, 2, or 3 electrons in its valence shells, it's got plenty of room for more electrons. It conducts current. A semiconductor has 4 valence electrons. And most of the time, there's no room for more electrons, and those electrons that are there are busy doing stuff with other atoms. There are molecular bonds there. But occasionally, 1 in 1,000 times, there is a semiconductor atom that has a free electron. And what we do to make these really work for us is we put silicon in a furnace with some impurities, and we cook the thing. And the impurities will either add just a tiny bit more electrons or just a tiny bit more holes where the electrons should have been, but they're missing. And that gives us two types of semiconductors. So here's your basic. I got these pictures out of a kid's book, by the way. I always find them useful to turn to. So here's your basic silicon atom, bunch of atoms. If you have a silicon atom that has been run into a furnace and the impurities have added extra electrons, this silicon carries extra negative charge, so we call that an N-type silicon, N for negative. Now another piece of silicon we might have put into the furnace with an impurity that will increase the number of holes, and a hole is a place where an electron should be, but there's not one there. There's a hole. And because these have fewer electrons than they normally would, they have a positive charge, and so we call them P-type silicon, P for positive. So we have plain silicon, and then we put impurities in the silicon in a furnace, and we get N-type, negative with more electrons, or P-type, positive with more holes. Well, here's the thing. Electrons carry current, as you know, and holes carry current also. In fact, if you want to start a big old discussion with a physicist, just start an argument about whether it's holes that carry current or electrons that carry current, and then just stand back. But anyway, they do. Both holes and electrons carry current, and it's how we put them together that makes semiconductor devices. So if we put a P-type and an N-type together, that place where they came together is called a junction. And electrons or holes tend to want to jump across that junction and flow if we apply some voltage. So in a diode semiconductor, a diode has only two, I've forgotten the name, like two wires, two connectors coming out of it. And It is essentially like a check valve for electrons. And here at the bottom of the slide is the symbol for diode. You can see it kind of looks like a check valve. So could flow one way, can't flow the other way. Here's what they look like if you wire them up in big scale electronic equipment. Usually, though, we are seeing these things as part of integrated circuits, computer chips. Down in the lower right corner is a symbol for a special kind of diode called a Zener diode. And then in the lower left corner of this slide is the symbol for another special kind of diode, the light-emitting diode, or LED. And what happens here is if electrons and holes come together, they will, and they do in these diodes, when they come together, they will give off a photon. A photon is a light particle. And so these diodes, with the holes and the electrons coming together, emit light particles. So they're LEDs. A transistor is, if you want to think of it this way, it's basically a switch. It's a semiconductor material that acts as a switch, and it's got 3 leads. That's the word I was trying to think of. 3 leads. If you see an object, here are some giant things like you might find on a circuit board. They have 3 leads. You know right away those are transistors. Here at the top of the slide is the symbol for a transistor when you're making a drawing. And you can see it has 3 leads, 1 coming out the base and 2 coming out the top. And they can be arranged, the positive, negative, and positive, the p-type silicon, n-type silicon, and p-type silicon can be sandwiched either NPN or PNP. If it's NPN, so negative, positive, negative layers, we draw the symbol this way. The arrow is pointing out, and the way to remember that that's an NPN is to think never points in. This arrow never points in. And never points in begins with the letters NPN. So that's the kind of transistor it is. Oh, let me back up. Then the PNP that does have the arrow pointing in is just the other one. And then you will run into all over the place a special kind of transistor called a field effect transistor, or FET. Electrical engineers talk about these all the time, and they are the building blocks of computer chips, these FETs. They switch on and off and regulate voltage, and they're very important. So there are semiconductors, and as we said, we will look at semiconductor material a little bit more in another week when we talk about integrated circuits and computer chips.